Greetings. This is the video for social science descriptive statistics. Today we're going to discuss descriptive statistics and how it relates to the social sciences, criminology, sociology, and so on and so forth. Basically, we use statistics to describe any given population in the social sciences, from something as silly as a bag of M&Ms to something more complex as a school population, or even more specifically, a classroom of students. So today, I'm going to give a quick example. I would say, imagine you have a group of students, and we'll have about 16 students, and we ask each student, "What is your age?" And we say, "Around the age, to the nearest year." And we ask them all this, and let's assume that they don't lie to us. Sometimes people do lie, but let's just assume that they tell us the truth. And we come up with the following ages. Somebody is 16. We have an 18-year-old. Let's say we have another 18-year-old in the classroom. We have two 19-year-olds, and let's say that we actually have three people who are 20, so we'll put their ages down. And let's also say we have two people who are 21, and we also have two people who are 22, and we have one person who's 24, one person who is 25, and we even have somebody who is 52 and another person who is 68. By the way, these ages could actually be pretty accurate. I've taught classes before, particularly at a community college. We had one student who was, I believe they were homeschooled, but they were still intelligent enough. They got into community college at about 16, 17. They wanted to do some college courses. So they were doing that. And that was pretty interesting. So what happened was we actually did have a really young student. It was almost kind of the exception. But I've also had other classes where we have what we call, at least as far as age is concerned, non-traditional students. So you might have students who don't meet the normal traditional age, but they are older and they still come back to school. Even in law school, I had a fellow student who was in their 80s, and it was really interesting because they just wanted to go back to school. I thought that was pretty cool. So it can happen. You do have classes that actually resemble this. But if someone said, "Hey, tell me about your class, describe it," what would you say? Well, one of the things you could say, we'll say n. This is the total number in our population. If we count all these numbers up, we actually get 16. Remember, we asked 16 students. So one of the things we could tell them, that's part of descriptive statistics, is that our population is 16. Now, when we discuss statistics, there are different types of statistics. One of the first types is, I'm just going to write it over here. One of the first types in descriptive statistics is measures of central tendency, and we also have measures of dispersion, or how much our data is spread out. Now, the first type, the central tendency type, we actually have, and this is probably going to sound familiar to you, but we actually have what's called the mode, the median, and the mean. I bet that sounds pretty familiar to you. And what we're going to notice is that for the mode, we'll start with the mode. The mode, by definition, is the most frequently occurring case or number in the distribution. We call these numbers a distribution. Okay, so that's pretty cool. But how do we determine the mode? Well, what you have to do is just look at the data. It's more of a visual inspection. But do keep in mind, when we figure out what the mode is, we also report it as a percentage of the population. And we call this the modal category. And the way we do that is by this nice little looking equation. And we really just write this equation like this. We say MO equals the frequency of the highest category over, and we just write N, which is the population. So let's do this real quick. Let's go all the way up. And what do we see? We see our data. Okay, we see 16, 18, 18, so on and so forth. If we look just by visual inspection, we notice that our mode is really 20. Because of all of these, we see 20 occur the most, which is actually 3 times. So of all the number of ages, we see 20 appearing the most. So we're going to say that the mode is 20. So we'll say mode 20. Actually, we kind of just write out. For this data, the mode is 20 years, which is, okay, now we have to figure this out, which is a certain percentage of the cases. So MO frequency, now we're going to do that. So MO equals how many times did this 20 appear? It went over 3 times. And we said the population was 16. So if we calculate 3 divided by 16, what do we get? We actually get 0.1875. And you can move the decimal place. And this turns into 18.75. So up here we're going to say, for this data, the mode is 20 years, which is 18.75%. And then we're going to write non-dominating. Of the cases. So 18.75% of the cases. And how do we know if it's non-dominating? Well, that's pretty simple. We say, is it more or less than 50%? If it's less than 50% of the cases, then it's not dominating. If it's more than 50% of the cases, it would be a majority. Therefore, it would be the dominating case. But in this case, it's not. It's not dominating. So what's the use of this? Well, it's basically if you want to see what the frequency occurring case in the distribution is. Of course, here it's not that much. It's only 18.75% of the cases. And its limitation is that it's kind of a crude measure. It, again, only tells us what the percentage of cases are in the modal category. So if you were to tell people, hey, look, the mode is 20, does that really tell them much about the data? Maybe, maybe not. But it's kind of limited. So now the next thing we could look at, and by the way, in order to do the mode, you need at least nominal level data, which basically is categorical. Anything, for example, as basic as gender, so male, female, or any other type of category that you could come up with that's mode. This is actually ordinal level data, which we'll talk about soon. But just note that you need at least nominal level data to perform the mode calculation. And again, that's mostly done by visual inspection, and we report as a percentage of the cases in the modal category. But then next, we want to look at the median. And the median is very useful. The good thing about the median is that, well, first of all, let me just give you the definition. The definition of the median is really that it's a position of measure. So what it really does is it identifies the category which is associated with the middle, that W slash means with the middle case in our distribution. Okay, so what does that mean? Well, what that means is, what we actually calculate is the 50th percentile. Which is pretty neat. And what this really does is it says it splits all the data right in half. So another way to look at this is if I were to draw a line of our data, okay, our median would actually fall right in the middle of that. So this would be our median right here, okay? What that means is to the left of that point is 50% of our data, and to the right of that point is the other 50%. So this median is right smack in the middle, which is pretty neat. And what we can do with that, and by the way, in order to calculate it, we need at least ordinal level data. Which means it has to have some order to it. So, and basically ordinal is nominal plus a sense of order. So what you have is there's no assumption of equal distance among the adjacent categories, but there is an order sense to it. And this is actually great to use. So if you really want to use this, it's used for highly skewed data. And this kind of meets our example because we have ages that are out there that you don't normally see. Think about income. If you have income, if we have a class, instead of asking age, if we went to all the students and we said, what is your average income for the year? Well, some of the students can say, I only work part-time. I might make at most 12,000. Some might say 30,000. So the average would normally be around there. But then, let's say you have a couple of students who come back to school and they've already made it big. They own their own companies. Let's say they make $1 million a year. Well, if we ask them and then we determine the average, those one or two students that make $1 million a year are really going to push up the average amount per student. And that wouldn't be too realistic because that would say that we roughly make more than what we normally do. It was going to say we normally make 50,000, 100,000, maybe even a quarter of a million, depending on how many students are the millionaires. So that wouldn't be too realistic. In fact, that's why you see the news report what the median level of income is, and what that would look like is normally you'd see a median. They would report it as here to here because this will show you percentage-wise. The rough middle part of the data is the median. So that's just one of the ways of looking at it. So the median could be more useful if we have highly skewed data. But it also has a limitation. And the limitation is that it doesn't really take all the data into account. And so by that, it's kind of a crude measure because we're only looking at the middle point. We're not really looking at much else. So, but let's go ahead and calculate it anyways. So our median is actually determined. We'll use this formula. And it's really this MC, which is middle case, equals 0.5 n plus 1. And by the way, one of the very first things we have to do when we calculate a median, it's actually a three-step process. The first process is we array our data. Then we use the MC equals 0.5 n plus 1 formula. And then we determine the middle case. MC. We determine the middle case. And how that's done is pretty simple. So we first array the data. We look up here. When we started writing our ages down, we just kind of randomly wrote them around, which wasn't too bad, so to speak. But it doesn't really look pretty.